We are taking a look at a function that is given by words, and we are also going to take a look at the graph of this function. So let's read the words that we have to work with. In 1960, the population in the United States was about 180 million. Since that time, the population has increased by approximately 1.2% each year. We're to use n for the population in millions, or t for the number of years since 1960. So our first task is to make a table of values that shows the U.S. population in millions from 1960 through 1965. So I'm going to make a table, and I type this up beforehand. The years are to go from 1960 up to 1965. It told us in the words in 1960 180 million, so I know that value, and I can fill that in. So to calculate the population in 1961, I have to use an increase by 1.2%. So percent always has to change to a decimal. I do that by moving my decimal 2 spots. So this would be 0.012. So I'm going to go to my calculator, and you'll see a few changes on the screen here as I do that, but I'm going to I'm going to multiply this decimal times this and then increase. So I'll add that on my calculator. So here in my calculator, I have my decimal 0.012, and I'm multiplying that times the original 180. And I get my answer of 2.16, and then I'm going to add that amount. So I just hit add because my calculator knows the answer I just got to the 180. And so I have a population of about 182.16 million. So if I go back to where I was making my chart, see, almost there, we have population of 182.16 million. All right, so in 1962, I need to repeat. So what I need to do is I need to take this decimal percent times my answer. So on my calculator, I'm not going to show you because you've already seen me type. I'll type 0.012, and I'll multiply that times the 182.16, and then I will add that answer to the 182.16. And so when I did all of that work on my calculator, I came up with a rounded value of 184.35. And then I repeat. So I'm going to take the same decimal. This time I'm going to type 184.35 and add 184.35. And so I ended up with 186.56. And I repeat using this new 186 in my calculation, and I got 188.80. And I did it one more time, and I got 191.07. So I have a function that was given to me in words. Those are the words at the top of the screen. I actually, by using those words, have calculated values. So I have a function given by data at this point. So the next thing that I'm asked to do is to make a graph. So we're going to use an x and y axis. And I'm just going to use the first quadrant because we don't have anything less than 0. My first column is my year. That is my input. That is my x value. That always goes on the horizontal. My second column is the population, and that is my vertical axis. That is the output of the function. So my beginning year is 1960. and then 61, 62, 63, 64, 65. All right. I do not have to start this axis at 0, just like I did not start this axis at 0. So I'm going to start like right here. And it looks like we go from 180 to 190. So we'll start with 180 right there. 81, 2, 3, 4, 5, 6, 7, 8, 9, 10. Need to go a little higher. 91. So 1, 2, 3, 4, 5. This would be 185 million. This would be 190 million. So we just want to use an even scale, although we do not have to start an algebraic graph at 0. So in 1960, we have population 180. 61, we have population of 182 million. 62, we're at 184 million, just putting dots. 63, 186, almost 187 million. 64, 188, almost 189, and 65, 191. So these are the population values that I have calculated. Now I have a function given to me initially in words. Using those words, I created a function given to me in data. Using that data, I created a function given by a graph. And so I can see that that graph is increasing, and I can start to describe it using the vocab we've learned. Next thing I'm asked to do is express in function notation the population in the United States in 1963. So it told me here to use n for the population based on t, the number of years since 1963. So I have n based on the years since 1963, or since 1960, so this is 3 years later. And the value of that is right here in my table, 186.56. So that's just practice using the notation that we have learned. So the output is the population, input is time since 1960, and the value. Next thing, it says verify that the formula n of t, 180 times 1.012 to the t power, will give us the same values as in the table. So this is where I'm going to my calculator, and we are going to type this in to our calculator where our calculator has a y equals, which is a new thing for us to do with our calculators. So give me a moment to get there. On my calculator, I could type the formula here, and I would have to type it every single time. So my calculator has a feature where I can look at a whole list of values at one time, and it's this y equals feature. So I use my y equals, and it asked me to type my equation. So the equation that I had been shown is 180 times 1.012, and then I use my caret key to the, and it had t power. Our calculator does not have a variable t, it only has x, and x is right here beside the alpha key. So there I have typed in the formula. Now I want to see a table of values. So in order to do that, I'm going to use the second and the window because that allows me to set up a table of values. Second window. So we'll start at 0 and go up by ones. You can change these if that's not how they're set. Now to see my table of values, I'll hit second and the graph button, which you can see shows me a table of values. So second, graph, and I see the exact values we had written down. So I see that in 1960, year 0, we were at a population of 180, 182.16, 184.35, etc., etc. So back on my PowerPoint, I have verified that I have gotten the exact same values that were in my table. The last question it asked me is, assuming the population has been growing at the same percentage rate since 1960, what value does it give for the year 2000? So what I want to do is to figure out how many years apart are 1960 and 2000. So I would take the year 2000, subtract 1960, and that's going to give me 40 years. So I'm going to go to my calculator with that information. So again, that's going to take me a moment. Here in my calculator, I'd like to just type this in because I only want to know one answer. So I need to get out of this chart that we were in. So I'll use second and the mode button, which allows me to quit. So using the formula, I have 180 times 1.012, caret key, and we said time was 40 years later. So enter. And we get an answer of 290 million. And if we take a look back at our PowerPoint, it says that the actual value was 281 million. So personally, I would say that an estimate of 290 million 40 years in advance is not off by a lot. Also, seeing that we didn't actually hit that estimate, I'm guessing that the population growth rate that we were given did not remain exactly constant for the full 40 years. So in review, what we are doing is working with a function given by words. From the words, we created a table and a graph. We also used our calculator to verify a formula.